This is example 7 from lesson 6.1. A plane leaves an airport heading south 50 degrees east at 450 miles per hour. After 2 hours, the plane makes a 90-degree clockwise turn to a new bearing of south 40 degrees west. If the plane travels this new course for half hour, A, find the plane's distance from the airport to the nearest mile, and B, to the nearest degree, find the bearing from the airport to the plane. All right, let's see if we can get a picture of this drawn. So we have the airport right here. And if this is going to be due south right here, the plane is going to leave 50 degrees east of south and stop somewhere in here. So this angle is 50 degrees. Then it's going to make a 90-degree turn clockwise. So this is going to be a right turn. And then the plane winds up at this place right here. And we are to find this distance here from the airport to where the plane is, and then we are to figure out this angle right here, which will measure the bearing from the airport to the plane. Okay, one thing we know is that the distance right here from A to, we'll just call this C, is, we're going to use that distance equals the rate times the time formula. All right, so the plane is traveling 450 miles per hour for 2 hours, which means that the plane has traveled 900 miles. That's this side right here. Then, from here to here, where the plane is right now, the plane is traveling 450 miles per hour for a half an hour, and that's going to give us 225. So this side right here is 225. So this looks like a classic Pythagorean theorem problem. I have a right triangle. I'm looking for the hypotenuse, and I know the two sides. So for A, we can say that A squared plus B squared is equal to C squared. All right, so let's see, 900 squared, that's going to give us 810,000. All right, and 225 squared is going to give us 50,625. All right, and when we combine those, that's going to give us 860,625. And then when we square root both sides, and we are rounding this to the nearest mile, so I have 927.6, so I'm looking at about 928 miles. So the hypotenuse here is about 928 miles. All right, now before we do B, let's see if we can get a better look at what's going on inside this triangle. All right, I have a right triangle, and I know that this side over here measures 900, and that this side right here measures 225, and that this is a right angle. I just found the hypotenuse, but I'm not going to use that. And I also know that this angle right here measures 50 degrees. All right, and I'm looking for just this side right here. So if I knew this side over here, then I could just subtract that from 50 and it would tell me what I'm looking for. And by the way, To get from the airport to the airplane, I hope you can see that we'll be traveling south and then east. We just have to know how many degrees there are right here. Okay, so with respect to this angle, which I just called M, we said this side over here was the hypotenuse. We just found that to be 928. This side down here is going to be the opposite side, and that means that this side right here is going to be the adjacent side. So it looks like I'm going to use the tangent to find this angle M up here. All right, so we have the tangent with respect to my angle M is going to be the ratio 225 divided by 900. This means that angle M is going to be the inverse tangent of 225 divided by 900. And so to the nearest degree, angle M is going to be 14 degrees. All right, so if the whole angle is 50 degrees and this piece over here is 14, then our bearing is going to be 50 degrees minus 14 degrees, and that's going to be 36 degrees. And so the plane, or the bearing from the airport to the airplane, is going to be south and then 36 degrees east.